Hello everyone, it is me, Dr. Tashada Tashoma. I am back with the third question. I hope you found the first two questions from my previous videos helpful and insightful. The third question says, a bullet is fired with an initial speed v at an angle theta with the horizontal. It takes a time t to reach its maximum vertical displacement, hmax. It hits the target point a distance r away and exactly in the horizontal level to the point where it was fired. Which one of the following statement is not correct about the motion of the bullet? A. The bullet hits the target at a time 2t after it was fired. B. Hmax is directly proportional to the initial speed v. C. R will be maximum if cos of theta is equals to radical 2 over 2. D. Theta should be different from 90 degrees to hit the target at a distance r. Before we proceed with answering this question, let me first explain what motion is, how many types of motion are there on their nature and the paths followed. Again, what is projectile motion? What are the concepts and the associated equations in projectile motion? Now, let me start with the definition of motion. Motion can be defined as the continuous change in an object's position relative to a reference point over a given time interval. Based on the nature of movement and the path followed, motion can be classified into 5. The first type of motion is linear motion. Linear motion is the motion along a straight line. As you have seen here, this simulation, the car moves along a straight line. Such type of motion is called linear motion. The second type of motion is rotational motion. Rotational motion is the motion about a fixed axis. Now here we have the rotation of a rigid body. This rigid body rotates about a fixed axis. Such type of motion is called rotational motion. The third type of motion is periodic motion. Periodic motion is repetitive motion occurring at a regular interval. Now, such type of motion is a periodic motion. This simulation shows us the motion of a particle along a circular path. So if the circle, the circle is a horizontal circle, so the speed of the object can be constant and the motion becomes periodic motion. So such type of motion is called periodic motion. The third type of motion is oscillatory motion. Oscillatory motion is motion that swings back and forth about a mean position. So when we look at this pendulum, if we deflect the pendulum from a certain point, it swings back and forth in a given mean position. Such type of motion is called oscillatory motion. The fifth type of motion is called random motion, motion that does not follow a predictable path. So such type of motion is mainly occur in gaseous particles, especially in gaseous particles. If we look this simulation, here we have gas particles. So the motion of these gas particles does not follow a predictable path. Now, let me pass to what a projectile is. Projectile motion is a special type of motion in two dimensions that under the influence of gravity. For example, here we have a simple simulation. Let us launch a certain object from this system. When we launch an object, the object moves or the object follows a circular path, and the only force that acts on this object is the gravitational force. If we neglect air resistance, the only force that acts on this object is gravitational force. Since we know that gravitational force is a constant force, it produces constant acceleration. If the acceleration of an object is constant, the motion is called uniformly accelerated motion. Therefore, in our case, the projectile motion has two components because it follows a curved path, the y component and the x component. So the force acting on the projectile is along the y component. Again, that force produces constant acceleration. So the y component of a projectile motion can be treated as uniformly accelerated motion. Again, in the absence of air resistance, there is no force acting on the object in the x direction. So if there is no force acting on the object in the x direction, the velocity of the object becomes constant. So if the velocity of an object is constant, the motion can be described using uniform motion. Now, let us see the equation of projectile motion. Now, for the y component, as I have said earlier, the projectile motion is uniformly accelerated motion. According to your grade 11 physics, in uniformly accelerated motion, the displacement of an object can be calculated by V initial t plus half at square. Taking this concept into the y component of projectile motion, because the y, as I have said earlier, the y component of a projectile motion is uniformly accelerated motion. The vertical displacement y can be calculated by Vyt plus half gt square. But we know that V1 has the velocity of the projectile. U has two components, the vertical component and the horizontal component. The vertical component is given by ui is equals to u sine theta. The horizontal component is given by ux is equals to u cos of theta. Therefore, when we substitute the value of ui here, the vertical component displacement of the projectile can be calculated by u sine of theta t plus half gt square. Since we know that gravitational force is a force that always acts downward, it produces a downward acceleration. So the sign of the acceleration should be negative, because by convention, a vector that indicates upward is taken as positive and a vector that indicates downward taken as negative. That is why here I have said acceleration due to gravity is a vector and it was directed downward. Its value should be considered negative. Again, for uniformly accelerated motion, the final velocity at any time t can be calculated by v initial plus a times t. Again, taking this concept into the vertical component of a projectile motion, the final velocity of the projectile along y component can be calculated by vy sine of theta plus gt. Since we have said that the horizontal component velocity is constant and the motion can be described as uniform motion, so the horizontal displacement x can be calculated by ux times t. But the horizontal component velocity is u cos of theta, so x can be calculated by u cos of theta times t. Now let us see special case. So when we are talking about special case, let me show you everything by using this diagram. When an object reaches maximum height, before it returns back, the y component velocity of the object is equals to 0. If the y component of the velocity of the object is 0, the y component of the velocity of the object is 0, 0 is equals to vy sine of theta plus gt. But we know that the value of acceleration due to gravity is negative. When we take this part into the left side, it becomes vy sine theta is equals to gt. So t is equals to vy sine of theta over g. That is why t is equals to u sine theta over g here. The other special case is when the object returns to its original position, the vertical displacement is equals to 0, and the time required to complete the whole flight is called total time or time of flight. So by taking the vertical displacement is equals to 0, so when we rearrange this equation, finally it gives us the time of flight is equals to twice of u sine theta over g. There is a relationship between the time to reach maximum height and time of flight. From these two relations, what we understand, time of flight is equals to the time to reach twice of the time to reach maximum height. Again, the maximum displacement or the maximum height can be calculated by the initial velocity square sine square of theta over twice of g. The other special case is when an object completes its flight, the x component displacement is called range. That means the maximum displacement, the maximum horizontal distance is called range. In order to calculate range, we have to use time of flight, because time of flight means the time after an object completes its path. Because of that reason, when we calculate the range r is equals to u cos of theta times time of flight. When we substitute the value of time of flight here, r is equals to u square sine of 2 theta over g. Now, from these three basic equations, from these four basic special equations, here we have the time to reach maximum height is equals to u sine of theta over g. The maximum vertical distance is equals to u square sine square of theta over 2g. Time of flight is equals to twice of u sine of theta over g. And r is equals to u square sine of 2 theta over g. From these special case equations, what do we understand? In the case of the time to reach maximum height, it is dependent on initial speed and the sine of theta. In the case of the maximum vertical displacement, it depends on the square of initial speed and the square of sine of theta. In the case of time of flight is exactly equals to twice the time to reach maximum height. In the case of range or the maximum horizontal distance, the horizontal distance is dependent on the square of the initial speed and twice the sine of the angle. Again, in the case of this horizontal range, if theta is 45 degrees, the range becomes maximum, and if theta is 90 degrees, the range becomes minimum. Now, let me show you this using experimentally. First, let us decrease the degree. Here we have 25 degrees. If we launch the projectile based on this 25 degrees, so it falls here. Its horizontal distance is about 19 meters. Again, if we arrange the angle into 45 degrees, and if we launch the projectile by 45 degrees, so its horizontal distance become about 23.9 meters. This means at 45 degrees, the horizontal range of a projectile is maximum. Again, if we launch a projectile at 90 degrees, here, now the object returns in its direction. That means the range is equals to 0. Therefore, let us go back to our question. The question says, a bullet is fired with an initial speed v at an angle theta with the horizontal. It takes a time t to reach its maximum vertical displacement h max. It hits the target point a distance r away and exactly in the horizontal level to the point where it was fired. Which one of the following statement is not correct about the motion of the bullet? A, the bullet hit the target at a time 2t after it was fired. Now t means the time to reach maximum height, and the twice of t means the time of flight or the total time. Therefore, range and total time are related to each other. Because of this reason, A is true. B, h max is directly proportional to the initial speed v. Since our equation says the maximum displacement is u squared sine square of theta over 2g, it depends on the square of the initial speed. Therefore, in B, it says h max is directly proportional to the initial speed. It is not true, because it is not directly proportional to the initial speed, but it is directly proportional to the square of the initial speed. The other one, r will be maximum if cos theta is root 2 over 2. We know that according to your mathematics lesson, cos of theta is equal to root 2 over 2 means theta is 45 degrees. If theta is 45 degrees, as we have seen in the practical case, the range becomes maximum, therefore C is true. D, theta should be different from 90 degrees to hit the target at a distance r. That means in order to hit the target, theta should be different from 90 degrees, because if theta is 90 degrees, there is no horizontal distance covered by the projectile. If theta is different from 90 degrees, there is a horizontal distance covered by the projectile. Because of this reason, in order to get a horizontal distance, theta should be different from 90 degrees. Therefore, this is also correct. So the answer for this question is B. For today, thank you very much. Have a nice time. Please share and subscribe this video. Thank you. Have a nice time. Bye-bye.